Welcome to the video lecture series on the subject called as Theory of Computation. In today's video lecture, we will be learning about the way of designing a deterministic finite automata. And this is Dr. K. N. Sivabalan. And to start up with, deterministic finite automata is also called as types of finite automata. So we have two different finite automatas. One is deterministic finite automata and another is called as non-deterministic finite automata. Now, in deterministic finite automata, we have at least one path for one specific input. That means we don't have more than one path for a specific input in a current state. Now, we will learn about deterministic finite automata in an elaborate fashion, the way of designing deterministic finite automata. Now, let us understand design a DFA for a string static with 0, 1 over an alphabet 0 and 1. Now, we have alphabets, two alphabets, but in this case, we have to design a string where the string should start with 0, 1 alone. So, now let us understand what is the language which can be accepted. So, L can be accepting a language can be 0, 1 or it can have 0, 1, 0 or it can have 0, 1, 1, it can have 0, 1, 0, so it can have 0, 1, 1, 1, so on and so forth. Now, you can just clearly observe that it always starts with 0, 1 in the entire language always starts with 0, 1. Now, the way of designing this diagram. So, how to design this diagram? Let us assume there is a state called as Q1 and that state is going to be the initial state. The initial state will be like this. So, Q1, when I apply the first valid input called as 0, I move to a state called as Q2. So, I move to a state called as Q2. So, the first valid input is 0. Now, if I apply the second valid state input called as 1, I am standing in the state called as Q2. So, I will just go to a state called as Q3. Let us make that as a final state. Okay. Now, in Q2 to Q3, I make 1. Now, this kind of diagram is will be only accepting 0 and 1. Now, if I have 0 and 1 followed by 0, if I have 0 and 1 followed by 1, or if I have 0, 1 followed by 1, 0, now this diagram will not be suitable. Now, in this case, so after starting with 0 and 1, 0 and 1 can be followed by anything. That means I can have a loop here. 0, 1 can be followed by anything. So, I make 0 and 1. So, it can be followed by anything. Now, the next case is, suppose if the first input is 0, what is the other possibility? There are two inputs called as 0 and 1. Suppose in Q1, if I give 0, you can go to Q1 to Q2. In case if 1 is applied, in this case, I cannot go to Q1 or Q2. In this case, I have to go to a state called as Q4. Let us make this state as a trap state. We will make this state as a trap state. So, in this case, I will make this as 1. In this state, I will just make this as 1. So, that means I will just move to a state called as trap state. So, in Q4, I can have 0 and 1. So, you can have anything in Q4. Once you enter the trap state, you cannot go to a final state. Now, after getting the first input called as 0, I go to a state called as Q2. So, what is a valid input in Q2? In Q2, you can apply only 1. If 1 is applied, you can go to a final state called as Q3. But if 0 is applied, what will happen? I should not stay over there. If I stay over there, then that will get accepted. So, if 0 is applied, I actually move to a trap state. So, now this is a diagram for DFA for accepting this kind of specific string called as 0 and 1. Now, I go to the next one and I go to the next one, a DFA for a string ending with 0 and 1 over an alphabet called as 0 and 1. So, now what is the ending string? So, let us assume that 0, 1 is ending, 0, 1, 1, 0, 1 should be ending now. And you can have 1101 should be ending, okay. and 1 1 0 1 0 1 should be ending, okay, so on and so forth. So it should end like this. Now let us assume that I will start with an initial string. So what is a valid string here? We should start with 0 1, sorry, we should end with 0 1. So we will make q1, let us make this q1 as an initial state, and q2. So I want to end the string. So when I give 0, I go to a state called as q2. Now when I give a state called as, when I give an input called as 1, it should go to q2 to q3. Okay. Now in this case, q2 to q3. Now this will actually end it. Okay. But what is a way of starting it? You can start with 1 also. When you can start with 1, so I can start with 1 here. So 1 can be repeated any number of times, 1 0 1. Now in q3, you can also end give 0 here. If you give 0, what will happen? If you give 0, I should actually come over here. I should actually come over here, 0. Then if 1 is given, it will go to q3 again. But what is the other possibility? 0 1, when I give 0 1 followed by 1. So once again, if it is the case 0 1 1, definitely it should not get accepted, isn't it? So in this case, when 1 is applied, I actually move to a state called as trap state. So I actually move to a state called as trap state. So let us make this trap state as q4. So when 1 is applied, we will be moving to a trap state. So q4 can be having 0 and 1 put together. So this is the diagram for a DFA for accepting a string which is ending with 0 and 1. Now what is the other mechanism for doing this? So designing a DFA for a string which accepts exactly 2 b's over an alphabet a comma b and accept the string ba. Now there should be maximum exactly only 2 b's here. So now let us, what is a language which can be accepted? So I can have bb as a valid input, I can have abb, I can have AB as a valid input, I can have ABA as a valid input, okay. So I can have ABB, AAA as a valid input, so on and so forth. So if I have only 2 b's, okay, exactly 2 b's is accepted. Now the way of designing this diagram is, we will start with Q1. Now you take only the first valid inputs. What are the valid inputs? B and B. So from Q1 to Q2, I apply B here. From Q2 to Q3, so we will make Q3 as a final state. We will make that as B now. Okay. Now, initially what we can do is, now this A can be repeated any number of times before this B here. So I can have A here. So we are not concerned about A can repeat at any number of times. During this course of B also, A can get repeated any number of times. Okay. Here also A can repeat any number of times. So all these patterns are accepted. That if I get one more B, what will happen? In this case, I have 2 B's now. If I get the third B, obviously that is not valid. So for example, if I get something like this, A, B, A, B, A, B. Okay, now obviously this is not valid because I am getting a third B. Now you will be standing in the final state when you get 2 B's, but when I get a third B, obviously it should not get valid here. So when I get a third B, now you go to the trap state called as Q4 and give B over here. And in trap state, if you get any number of A's and B's, you stand over there. Now this is a diagram for accepting a trap state, accepting maximum of exactly 2 B's over here. Now what is a string which has been given? I want to accept the string called as AB, ABA. Now we will perform the simulation for this. So acceptance, otherwise we will say it as acceptance of a string, acceptance. Okay. So what is the string here? So delta of q1, the string is called as ABA. Okay. Now we will make a continuity symbol. What is continuity symbol? So this and this will be continued in a line. Now apply input A on Q1. When you apply A on Q1, so you will go to Q1 itself. So Q1, and what will be remaining? BA. Okay, BA will be remaining. Now again, now B is applied in Q1, so I go to a state called as Q2, and B goes off. What will be remaining? ABA will be remaining. Now in the third case, okay, when A is applied in Q2, so when A is applied in Q2, we will be standing in Q2 itself. So delta of Q2 BA. Okay, now we are standing in Q2 when B is applied. When B is applied, we will go to Q3. So I go to Q3 here. Now you have only A left over here. Now in Q3, when A is applied, we will be standing in Q3 itself. So you go to Q3, so it is accepted. Now this is called as a DFA for accepting exactly 2 B's. Now going to the next one. So design a DFA which accepts at most 2 A's. At most 2 A's. So what is the meaning of this? That means the minimum 1 A can be there, maximum 2 A's can be there. So L is equal to, what is the language which is accepted? A is accepted, AB is accepted, AB, A is getting accepted, or AAB is getting accepted, or BAA, B is getting accepted, any form. Okay. So all these are getting accepted. So what is the process? How to do this now? So we will start with the state called as Q1. So let us make that as an initial state. So when first A is given, okay, at most 2 A's. At most 2 A's is, even if 1 A is getting given, that will be getting accepted. So now I make Q2 as a final state. Q2 is a final state means even if 1 A is given as an input, that should be accepted. So now this will be accepted. Okay. Now what will happen if I give one more A? One more A means that will also get accepted. So I stand in the state called as Q2. Now I have to move to the state called as Q3. Q3 is also called as a final state. When second A is applied, it should be going to Q3. But what is the problem here? At most only 2 A's can get accepted. But if I apply the third A, it should never get accepted. So I move to a state called as Q4, make that a state as a trap state. So when I apply third A, it should go to Q4. Now this Q4 can have any number of A's and B's. But in between this, we have only inputs for A, but B's can get accepted in any number of times. So here I can have any number of B's here. So here also I can have any number of B's, and here also I can have any number of B's. Okay. So my concern is only about A, not about B's. Now this is the diagram for design DFA which accepts at most 2 A's. Now what is the other way of doing that? What is the other way of doing that? Now we have DFA which accepts minimum 2 A's and maximum 3 A's. Okay, so what is minimum 2 A's? So L is equal to AAB is accepted, BAA is getting accepted, BAA should get accepted, ABAA should get accepted, all these things. Okay, so there can be minimum 2 A's and maximum 3 A's. Now what is the way of doing that? So we will have initial state called as Q1. So Q1 tends to Q2. Now when I apply the first A, I should move from Q1 to Q2. Now when I apply the second A, that definitely it should get accepted. That minimum 2 A's has to get accepted. So Q3 I make that as a final state. Okay, So Q3 I have to make that as a final state. When I give 2 A's, it should get accepted. When I give the third A, I will be standing in Q3. So I just move to a state called as Q4, make that also as a final state because 3 A's should get accepted. Minimum 2A and maximum 3A should get accepted. So this will be giving me the answer called as up to 3 A's. But now B does not have any restriction. Okay. Now in Q4, when I get a fourth A, definitely it should not get accepted. So I move to a state called as Q5, make that as a trap state. Now this Q5 is a trap state, will accept A and B together. Okay. Now there is not any restrictions for B here. So B can have any number of times B here. And here also I can have any number of B's, and here also I can have any number of B's. Here also I can have any number of B's. Okay. So that is the mechanism of designing a DFA for this specific pattern. Okay. Design a DFA that accepts even number of A's and even number of B's over an alphabet and accept the string called as ABBA. Okay. So this diagram is a little bit crucial diagram. Now see here. So what is the language which is accepted? A tends to B should get accepted. AB should get accepted. BA should get accepted. AB and AB should get accepted. Okay. So now in this case we will have Q1. So Q1 we can have Q2. Let us assume that this case this way I am going. So let us make this Q1 as a final state. So when I give first A, okay, it goes here. When I give the second A, it comes back. That means even number of A's is getting accepted. Okay. Now what do you have to do for even number of B's? So I will make here Q3. Now when I give a first B, it should come to this one, and when I give the second B, it should come back to final state here. Now, and when you just closely observe, this accepts AA, BB. But if I give AB, now there is not any path for this. When I go to give the first A, it comes over here. There is not any path for B, isn't it? So I just make here Q4. So here I just give B here, and I just come back for this B. Okay. Now if I give AB, again A, there is not any path. Okay. So in this Q4, when I give A here, it goes here, and when I give A again, it comes here. Now we can closely observe that this diagram can accept even number of A's and even number of B's. Now what is the state here? So we have to accept AB, BA. Okay. Now we will accept this acceptance of a string. So acceptance of a string. So delta 1, we will make Q1. So A, B, A. Now the next case is when I apply Q1A, you will be coming to Q2. So delta of Q2 BA. So Bn. Now in Q2, when I apply B here, we can go to Q4, isn't it? So delta of Q4 BA. So in Q4, when I apply B, it will come back to Q2. So delta of Q2, and what is remaining here? A is remaining. In Q2, when I apply A, you actually come back to Q1, that is called as a final state. So it is accepted. So thanks for watching a video. Have a good day.